Hello. So continuing on with hyperbolas, we have our roadmap here, which is in your textbook, and we have to find the vertices and the foci of the hyperbola, this hyperbola. So when we're practicing these a lot, we can see, hopefully we can see that eventually, that this one will be facing left and right because of the subtraction sign. Subtraction is not commutative, so again, order matters. And the subtraction sign is tied to this coefficient, 16, which is connected to y squared. So the y squared portion is being subtracted, is what I'm trying to say here. And if you look at these two options, the one that faces left and right has the y part being squared, being subtracted. So I know that that's the case, that this hyperbola is facing left and right. And it does not look like the standard equation. The standard equation equals 1. So I'm just one division away. Realize there's lots of ways to make 64 into 1. I could subtract 63 from both sides, but that's not going to help me at all. So the more you learn about math, the more you have to kind of discard things that won't help you. But of course, I could just subtract 63 and that would equal 1. But I know that I want to land on an equation that looks like this. So I'm going to divide by 64. And when I do divide by 64, 4 divided by 64, the 4 will cancel out with the 4 that's in here. 64 is 4 times 16. So when that 4 cancels out, I'm left with really just division by 16. And 16 is also a factor of 64. It's 16 times 4. So when I divide by 64, the two 16s cancel out, leaving me with 4. Now it's in standard form. So I know lots of things. First of all, HK, which is the center. The center is 3, 0. And this is a squared. A squared happens to be bigger here, but that's not a necessity for hyperbolas. A squared is just the one that's mentioned first. So a squared is 16, which means a is 4, and b squared is 4, which means b is 2. And I have to find the vertices and the foci. Well, the vertices are a away from the center. So I know my center, and I know I'm facing left and right. So looking at this, if I'm facing left and right, then the vertices and the foci are also left and right of the center. And remember, this is called the transverse axis, the thing that connects the two vertices. So I have to go A to the left and to the right of the center, which is just adding and subtracting A to the X part of the center. So the two vertices are negative 1, 0 and 7, 0. Now the foci are C away from the center, and I don't know what C is. So I have to think about, how do I find C? And I use this Pythagorean relationship. C squared is A squared plus B squared. So since I know the foci are C away, I'm finding C. I know A squared. A squared was 16. B squared is 4. So C squared is 20. And so C is rad 20. But rad 20 equals rad 4 times rad 5. And rad 4 is exactly 2. So C is 2 rad 5, which is bigger than 4. Because remember, the vertices are A away from the center. The foci are further away. So if I had to go 4 to the left and right to get my vertex, each vertex, I have to go more than 4 to get each focus. And so I'm just trusting that 2 rad 5 is going to be bigger than 4. I go to my calculator to find out, and I add and subtract that value to x. So 3 plus 2 rad 5, 0 is one focus, and 3 minus 2 rad 5, 0 is another focus. But the best way to write this is 3 plus or minus 2 rad 5. If you can use fewer words to say the same thing, it's always better. Unless you're taking a test in this class, you have to show your work. Next example. Find the equation of a hyperbola that has these foci and a conjugate axis length of 4. So if the foci, remember, are C away from the center, and look at these two foci. The X the x is not changing. The y is changing. So that should tell you that our hyperbola is facing up and down. So, and then the center is always, the center is c away from each focus. Or you could also say the foci are c away from the center. So what is the ordered pair that's right in between these two? It definitely has an x value of 2, but what's the y value? So what's the y? What y value is between -4 and 2? It is -1. So the center is 2 comma -1. And if you know the center, you know hk. And I had to find the equation. So I need h, I need k, I need a squared and b squared, and then I'm done. And I just found out h and k. Furthermore, since I know the center and I know the foci, that should mean that I know c, because the c value is just the distance from the center to the focus. So I had to go 3 up and 3 down to get these two foci from this center. So c is 3. And yes, I already knew that. Okay, so it's facing up and down. So I'm looking at this one right here. What's next? The conjugate axis length is 4. Remember, the transversal, the transverse axis is the one that connects the two vertices. The conjugate axis is the one that's perpendicular to that. So in this drawing, I was given the red length. The red length is 4. But the conjugate axis is always 2b long. See, this the semi-conjugate axis is b. Semi is half. So if the conjugate axis has a total length of 4, that means half of that length is 2, which means b is 2. So b squared is 4. So look at what I've got. I want to find the equation. I've got h, I've got k, and I just found out b, which means I have b squared. So I have all of this. Remember, h is the x value of the center. So that 2 needs to go with the x. And the -1 is the k part of the center, so that has to go with y. And I don't know a squared, but I know everything else. So how can I find a squared? The best way, and maybe the only way, is to do the Pythagorean relationship. C squared is a squared plus b squared. We know c, so that means we know c squared, and we know b squared. So I'm going to use that to find a squared. C squared is 9. I'm looking for a squared. So right there, a squared is 5. And I made a mistake. I went one step further. This is unnecessary. I guess it's just the inertia. A is rad 5, but when is the only time I really care to know what A is? If I wanted to find the vertices are A away from the center, but that's not what's being asked. I just want to find the equation. In the equation, I need H, I need K, I need A squared, I need B squared. So I should have stopped when I found out what A squared is. And then I replace A squared with 5, and I've got it. This is the equation of my hyperbola. Let's see here. We'll save these last two examples for another video.